The herring apocalypse, fish worth millions in exports die in Icelandic lake. Sam Webb. Daily Mail. Tuesday, February 5, 2013, 1810 CST. The Dead Sea. Millions of pounds of herring lie dead, believed to have been killed by building work, stretching as far as the eye can see. Dead herring blanket the ground in these chilling pictures taken today. It is not yet known what is causing the mass fish deaths in Iceland, but today's grim find is the second such occurrence in 2 months. The herring, weighing an estimated 25,000 to 30,000 tons and worth £18.9 million, were found floating dead in Kolgrafafjord, a small fjord on the northern part of Snæfellsnes Peninsula, West Iceland, according to the country's Morgunblaðið newspaper. Biologist Robert Arnar Stephenson estimates that 7,000 tons of herring is laying on the shore, and there are many more at the bottom of the fjord. Both this mass death and the one in December, where a similar amount of fish died, are thought to be due to a lack of oxygen in the fjord caused by a landfill and bridge constructed across the fjord in 2004. Fears over the costly deaths have prompted the Marine Research Institute of Iceland to visit and gather information, while government ministers agreed to allocate money to research and monitor the situation. School children in the nearby village of Grandarfjörður collected between 25 and 30 tons of the dead herring this morning for sale as animal fodder. They raised an estimated £1,000 for use in sports and other activities through the collection. The herring will be left to decompose naturally, according to a decision by the Environment Agency of Iceland and the West Iceland Centre of Natural History. Nearby residents complained about the smell of the rotten fish, and there is an ongoing dispute over the clean-up. Tens of thousands of birds have been drawn to the site to feed, but there are fears the fish oil from the decaying herring might threaten these birds in the coming weeks and months. The fishing industry is a major part of Iceland's economy, accounting for approximately half of the country's total exports.
If we look back in a geologic chart to the last ice age, and a lot of people say, well, I know sea levels changed, but they probably don't know how long. The last ice age maximum was 20,000 years ago. And sea level was down 390 feet below where it is today. It's an astounding amount. And it rose not smoothly, a little bits of bumps, but then 14,000 years ago, it rose in a sudden step you can see there in the middle. It rose 65 feet in 4 centuries. That's 1.5 feet a decade for 40 decades. Hard to imagine. And that's by nature. That's no impact of man. So it can happen even in nature. We've had an ice age for pretty much the last 5 million years, about every 100,000 years. And that top graph shows almost 1 million years, 900,000. And it shows the pattern of the ocean in blue going up and down. And then in the lower part, kind of does a blow-up of the last ice age cycle, the most recent 140,000 years. What's particularly noticeable here is 2 things. One, that the pattern of peaks of the ocean going up and down 300 or 400 feet is pretty regular. It happens between 95 and 125,000 years. So call it 100,000 just to keep it simple. But more interestingly, the ocean dropping and rising that 300 or 400 feet doesn't happen evenly. It goes down for about 80,000 years and it rises for about 20,000 years. The truth is, until I did the research for this book, I never quite grasped that 20-80 split. But it's really important because 20,000 years ago, the ocean was down almost 400 feet. And if you look at the pattern, we're at the top part of the pattern. we should be at the time, not this week or this month or this year necessarily, but this era, we should be at the time when we're rounding the corner at the warmest point, when the ice sheets are at their minimum and sea level's at its maximum, right? Temperature melts ice, which raises the ocean level, and beginning the 80,000 year decline toward the next ice age. But we're not going to have that problem anymore. We've kind of solved the problem of the ice ages. We're not going to be entering the next ice age because we're warming. And this puts it in perspective that we've actually changed the natural cycle. I used to say we've accelerated climate change. We haven't accelerated climate change. This makes pretty clear that we have changed the direction. We've actually interrupted the cycle in the last 5 million years. For every, on a global average, and it does vary greatly, but on a global average, the geologic rule of thumb is that for every foot of sea level rise, that the shoreline will, on average, 300 feet inland, a football field. We're going to get to a level in the next 2 centuries that hasn't been seen on Earth for 13 million years. And that's a geologic fact. But after 6,000 years of stability for sea level and the shoreline, we're in a new era. And sea level is rising, and that means the shoreline is going to move inland. And it truly is a new era. It's different than the last 6,000 years, so that's the big news story. It's probably the big news story of the century. Because at the end of the century, when we're all gone, but our kids, grandkids, or the next generation will be here, this place is going to look different. Again, just a simple illustration that if we look at the shoreline, kind of just in a diagram, we have the sea level is the base, then there's high tide, and then there's storm surge, and then if storm surge hits at high tide, each of them raises the level and means that the water is going to come further inland, obvious. I have control my clicker. When we go to the beach, there's a bit of an illusion. The illusion is that the beach is permanent, that it's always been there and always will be. I have that sense too. But the reality is the shoreline's only been there for about 6,000 years. The reason we think that's permanent is that's kind of how long we go back in our human records, our written records. And most people would say that human civilization doesn't go back much more than 6,000 or 8,000 years. But the shoreline is only there, the green arrow, as long as sea level is there. And it's not always been there. Because the polar ice cap has been frozen for 3 million years. When I dove under the polar ice cap in 1985 and did this cover magazine article for one of the diving magazines, there was essentially no concern about the ice sheets melting, the polar ice cap melting. It was still 10 feet thick ice. We had to drill holes through 10 feet of ice to dive under the polar ice cap in 1985 and 87. And it's stunning underwater. I wanted to dive there for years, and as I said, I did 2 different expeditions up there. It's clear, it's obviously extremely cold. It's 29 degrees Fahrenheit because it's near freezing seawater. But when we step back today, most of you have probably seen some images of this. The polar ice cap is now clearly disappearing. It was not considered possible when I studied ancient ice ages and sea level change in 1972. It was not deemed possible for it to be gone this century. That really only began to be a consideration back in the 80s, and each decade it's gotten more and more real. The fact that it's been frozen for 3 million years and that the Arctic will be essentially ice-free in most of our lifetimes is the best testament possible to that we're in a new era. To raise the level of liquid in the ocean or in a glass, you have to add ice from outside or add liquid. And to see that happen, we have to go next door to Greenland, which is mostly above the Arctic Circle, but is a big island covered 90% in ice that year by year is melting more and more. Here's a picture taken in 2006. Antarctica has bigger mountains than Greenland. It's a bigger island, and the ice is thicker. It's up to about 3 miles thick. As a result of that, being a bigger island and thicker ice, it has 7 times the amount of water as Greenland. So if you multiply the 23 I gave you a minute ago, you'll realize that when Antarctica melts entirely, which certainly can't happen this century or next century in entirety, sea level will rise 160 or 70 feet. Methane is increasing. If we burn it as an alternative to coal, it's actually a cleaner energy. And that's pretty good. The problem is when methane escapes unburnt. If methane gas itself gets into the atmosphere, it'll slowly degrade into carbon dioxide over many, many decades. And over the course of a century, as it degrades into carbon dioxide, it's about 20 to 25 times stronger as a greenhouse gas than carbon dioxide. What even most scientists haven't researched, because scientists tend to specialize, and what I did is look at all the issues of sea level rise and then wanted to translate them so that non-scientists could understand it. What most scientists don't even understand or haven't just researched is that methane in its pure form is 250 times more powerful as a greenhouse gas. That by the time it's degraded over 2 decades, it's 72 times more powerful as a greenhouse gas. Call it 7. So it's far more powerful. Now, the amount we're putting in the atmosphere, fortunately, is tiny compared to the amount of CO2 we're putting up there. But it's something to pay attention to because there are lots of sources for methane. And at those multiplier factors, whether it be 25, 72, or 256, methane is a problem. For those that want more information, I've got a website, johnenglander.net. There's a free special report about Sandy, 6 pages, 10 lessons from Hurricane Sandy, since my book came out before Hurricane Sandy. You can download that there for free. Occasionally going to do some updates, and I'm even looking at some possible ways to get some campaigns going. My book, High Tide on Main Street, Rising Sea Level and the Coming Coastal Crisis. It's available on Amazon and on ebooks, all the ebook formats.
People would laugh.